Let us see some more examples on finding the volume of a solid obtained by or generated by revolving a region. Okay, on question number 28 from the book, it says define the volume of solid generated by revolving the region bounded by y equals to 2, x plus 1, y equals to 0, x equals to 0, and x equals to 6, about x-axis. Okay, if you draw the graph of this is what it looks like. Okay, this is x-axis, this is y-axis. Okay, this is 0, this is say 6. Okay, and if you draw the graph of y equals 2x plus 1, so it will look like this. Okay, when x equals to 0, y is 2, so it will look like this. It will look like this. Okay, that's y equals to x plus 1, y equals 0 is this, x equals to 0 is this, and x equals to 6 is this. Okay, so this is the region bounded by these equations, right? Now what do you want to rotate it? What do you want to revolve this figure is? You want to revolve around x-axis. So if you revolve around x-axis, then the solid look like that, right? And then if you revolve it, that's what the leftmost side section look like this, and rightmost side section look like this, right? So it is basically a solid. There is nothing, no empty space inside. It is a purely solid. Okay, now how do I find out the volume? Volume is equals to pi and then a to b, right? And then radius is square, right? Radius square and then dx, right? So what will be the radius of the solid? For example, if you pick a disk here, let's suppose that this is a disk. Okay, random disk you are picking. So what is that radius? Because the area of that disk will be pi r square, but we are adding the area of all the disks from 0 to 6. That's why we'll be writing equals to pi and then 0 to 6, integral 0 to 6, right? R will be that value. That value is basically y coordinate of that point, right? So y is basically 2 over x plus 1. So 2 over x plus 1, and then you do square, okay, and then dx. Okay, that's what you do. So what do you get? If you square this, you will get 4 pi 0 to 6. You can write x plus 1 to the negative 2 dx, right? Why is that? Because the square of 2 is 4, and then I pull that up to the front because it is a constant, and then there will be x plus 1 square on the bottom, right? So if you move that to the top, this is what you get. But do you know that one formula? It is like ax plus b to the n. The integral of ax plus b to the n dx will be ax plus b to the n plus 1, okay, and then divide by a times n plus 1. If you compare this with that, you have a is 1, b is 1, and then n is negative 2, right? So it will be negative 2 plus 1. So basically this is what you get, 4 pi, right? 4 pi, and then x plus 1 to the negative 2 plus 1 over a is 1, so it is negative 2 plus 1. That's what you get, and then this is 0 to 6. Okay, so if you simplify this, what you get is you will get 4 pi, okay, and then what you get on the bottom, that will be basically like negative, right? And if you move this to the bottom, it is negative 2 plus 1 is negative 1, so you will get basically 1 over x plus 1, positive sign, because negative 2 plus 1 is negative 1 in the numerator. If you move that to the denominator, that's what you get, and 0 to 6. Now what I'm going to do is I'm going to plug in 6, and then I'm going to plug in 0 here. Okay, what do you get? 4 pi, let us plug in 6. What do you get? Negative 1 over 7, and then minus, let's plug in 0, so it will get negative 1 over 1. You see that? That's what you get. So if you simplify this, you will get negative 1 over 1 is that's basically positive 1 here, because negative is positive 1 minus 1, so it will be 6 7, right? So the things inside the bracket will be 6 7, and there is a 4 pi, that will be 24 over 7, and then there will be pi. That's what you get. Okay guys, that's what the basically we are doing the same thing, because on this problem you are basically rotating about x-axis. Okay, so we didn't have any problem finding the radius. Here radius is changing all the way from the left end to the right end. That's why we writing y is depending on x. That radius is depending on x. Okay, so the next example is example number 29, which is you are again find the volume of the solid generated by revolving the region bounded by y equals to x squared plus 1, y equals to negative x squared plus 2x plus 5, and then x equals 0, x equals to 3. Okay, that's what it is. So, and you are again rotating about x-axis. Okay, if you draw the graph of this is what it'll look like. The graph will look like. Okay, if you draw the graph of this, the graph will look like, because you are this is x equals to 0, x equals to 1, 2, 3 will be here. Okay, we will be plotting only in this region. Okay, so if you plot that negative x squared plus 2x plus 5 in your calculator, okay, so if you do that, then you will get like this, and then another graph y equals to x squared plus 1 look like this. Okay, that's what it looks like. And then since you want to find out the between x, what is x equals to 0, x equals to 0 is that one, right? And x equals 3 is like that one. So basically this is the reason that you want to revolve that part and then that part only. You see that? That's the part that you want to revolve, and you want to revolve around x-axis. Okay, so it is hard to draw the picture of the revolution here, but what we can do is, because we know that, so first of all we need to find out where they intersect to each other, what is this point of intersection. Okay, so first of all we'll find out that point of intersection, and then for this one we know that this is 0, right? And then this one is 3, the last is 3. Now we need to find it, because you see that, so this one is y2. Let's say that this is y2, this is y1. Okay, and this one is y1. This curve is y1, and the other, that is the problem that is opening downward, is y2, right? So on this piece that y2 is on the upper, and on this piece that y1 is on the upper. You see that? So that's what we will be doing. Okay, so to find out this point of intersection, how do you do that? You just set that them equals. Okay, so y1 equals to y2. If you do that, it will give you this point of intersection and that point of intersection, but we'll need just only that one, because this is the region that we are interested in, right? So write x squared plus 1 equals negative x squared plus 2x plus 5, right? So if you bring that to the left side, you will get what? 2x squared, because you are basically, what you are doing here is you are adding x squared, subtracting 2x minus 5. So adding x squared, subtracting 2x minus 5. If you do that, then what you get here is 2x squared, x squared plus x squared is 2x squared, and minus 2x minus 4 equals to 0, because right inside there all of them cancel out, right? So if you divide by 2, you'll get x squared minus x minus 2 equals to 0. See that? Now how do you get the factors? You get basically x and then x, right, equals 0. We need two numbers whose sum is -1, so it will be -2, +1, right? And the sum is -1, product is -2. That's what you get. So what you get is, this implies x equals to 2 and then x equals -1. This will be -1, and that point of intersection, that is basically 2. That's what you get, right? So what you will be doing is you will be finding out that guy. Okay, because to find out the actual radius, it will be like the volume of all the bigger solid minus volume of the hollow solid here, right? The hollow part or the empty part. It's like what we did last time, okay, in the last slide. Similarly on here, we will be doing the same thing. Okay, so what will be the volume then? Hence volume will be pi for this part, when you revolve it, it will look like, you see that will look like, I don't know, that will look like this, and then like that, and then that's what one solid look like. You will be doing that, and it will be doing like, when you revolve it, it will be doing like that, right? And then it will be again, it will be the same thing in this way. So it is hard to show that all the figure there, but how it works is you write that 0 to 2 for this part, 0 to 2, right? So this is y1, this is y2. So pi is already, so you write y2 2 square, because the upper one is y2 square minus y1 square, right? And then that will be dx, and then plus for the other one, it will be like for this part, right? For this part, it is again another pi 2 to 3, and then this is y1 square minus y2 square, and then dx. Okay, now we plug in the value of y1 and y2. So it will be pi 0 to 2. What is y2 square? Y2 square is that one, right? Negative. So negative x square plus 2x plus 5 square minus y1 square is x square plus 1 square dx. Okay, and then plus pi 2 to 3, and then you will be doing y1 square is x square plus 1 square minus y2 square is negative x square plus 2x plus 5 square, and then dx. Okay, so you can just do manually. You can just FOIL this, multiply this twice, multiply that twice, and then do the same thing here, and then integrate and plug in the limit, or you can use calculator for that. Okay, to use the calculator, what you need to do is you need to press math, and then go scroll down, move your cursor down to get the n integral. Okay, just integral, and if you click that, it will open up, it will open up like this box here, this box here, this box here, and then d, and then a box here. So you type x here, and then you plug in these values for the first time, like 0 to 2, and then find out that, and then similarly you do the second one. Okay, so if you do this, you will get, for the first one you will get 152 pi over 3 plus, and then you will get 125 pi over 3. This is what you will get. The pi is already there, right? So this part is 152 over 3. The second part will give you 125 over 3, and if you just add them, you will get 277 over 3 pi. That's what you get. Okay, that's how you get the final answer. Okay guys, all right, so the next problem that I want to do is question number 35. Okay guys, question number 35. So this is revolving about y-axis. Okay, so it is 9 minus x squared, y equals to 0, x equals to 2, and x equals to 3. If you draw the graph of that, and then you are plotting again around y-axis, right? If you draw this, 9 minus x squared will look like that. This is 9 minus x squared. Okay, because when you plug in x equals to 0, that you will get y equals to 9. If you plug in y equals 0, you will get x equals to positive 3 and negative 3. It will look like this here, but since it is x equals 2 and x equals 3, x equals 2 maybe somewhere here, right? 1 2 3, so that is x equals to 2, and this is x equals to 3. Okay, so you are basically rotating just this piece about what? About, you are rotating about y-axis. Okay, you are rotating about y-axis. How that look like? That will look like, if you rotate this piece around the y-axis, then it will look about like this. It will come down here, and then like this. You see that? If you rotate this, then the solid look like this. Okay, and then that's what the solid look like, and you will see that shading all around like that. Okay, it is a solid like that, which is basically kind of the interior part is a cylinder, the exterior part you can think of a cylinder, but what is changing is the x coordinate is changing. Okay, for the interior cylinder, the volume of the interior cylinder is pi, and then r square. R will be x, that is x equals to 2 for that interior cylinder. For the exterior cylinder, the r is again x is changing. Okay, for this x is one value, for this one x is another value, for the top one x is another value. X is changing, so you will have to solve this function. Okay, this function y equals 9 minus x squared for x. Okay, so if you do that, let me write down here. So 9 minus x squared equals to 0. Okay, so x squared equals to 9, so x equals to plus minus 3. Okay, so that basically x equals to, so 3 is the radius. So basically what is happening here, I'm sorry, it's not 0 there. Okay, so we need to solve for x because the radius will be x equals to y, right? So what do you get? You will get x squared equals to 9 minus y, right? So x equals to root under 9 minus y. That's what you get. Okay, so to find out the volume of the solid generated by the revolving this shaded region, you will get a solid that has empty in the middle, and but around that it is like a ball, but that ball has the radius changing. On the bottom bigger radius, on the top smaller radius, like that. Okay, so what will be the volume then? So the volume equals to pi. Okay, what is the, because again we are revolving around the y-axis here, or the vertical axis, so you will have like a to b and then dy. So you need the limits of integration for y. What is the smallest value of y? 0. What is the biggest value of y? That is 9, right? You see that the biggest value of y is I should not say 9 because we are not rotating up to 9, but what will be the value of y when you plug in x equals to 2? When x equals 2, that's the value you get, right? When x equals to 2, you get y equals to what? 9 minus 4. 2 squared is 4, right? So 9 minus 4 is 5. That's what you get. So 0 to 5, not 0 to 9. Okay, 0 to 5, and then you will be doing that square, x square minus 2 square. That's what you get. Why x square minus 2 square? Because if you pick a random disk, the outside disk, it will be the x coordinate of that curve is the radius. For the inside disk, you see that? For the inside disk, 2 is the radius, right? For the inside disk, 2 is the radius. For the outside disk, it is what? It is x is the radius. So that's why I'm doing the volume of the outside cylindrical shape minus the volume of the inside, that empty cylindrical shape. Okay, that will be pi 0 to 5. What is x? That is x squared is 9 minus y, right? So 9 minus y, and then minus, because x is 9 minus y root, x squared is that, minus y 2 squared is 4, and then dy. You see that? That will be pi 0 to 5. 9 minus 4 is 5 minus y dy. You can use calculators, but it is easy to calculate, right? 5y minus y squared over 2, but the limits are basically 0 to 5. If you plug in 5 pi, you will get, plug in 5 here, 25 minus 25 over 2, and then minus, plug in 0, you will get 0, right? So that will be 25 pi over 2. That is the final answer. Okay guys, so this is basically this is the concept that you do the problems on this section. Okay, so I will give you one more. The last example here is question number 37 from the book. Okay, it says find the volume of solid generated by revolving the region y equals to sine x, y equals to 0, x equals to 0, and x equals to pi. So how that the y equals to sine x look like? Y equals sine x look like this, right? It will go like this, and then it will go like that. It keeps doing that in both directions, right? So this is 0, this is pi. So what it is saying is, you are trying to find out the volume of a solid. You are revolving this solid around this axis, right? How that look like? If you revolve this solid, the resulting solid will look like that, right? That's what the solid will be. And then and then if you take a random disk, let's take a random disk here. That is the random cutting or the intersection of that disk. So what will be the radius of that? Radius is basically y, right? That is the y coordinate, is the radius. Y equals to sine x is the radius here. You see that? So what will be the volume then? So volume equals to, let me use a little bright color, it is pi and then integral 0 to pi, right? And then radius squared is sine x squared dx. You see that? So that will be pi 0 to pi sine squared x dx. Do you remember how do you find out the integral of the sine squared x? We need to change that into the multiple angle formula, right? What is the formula for sine squared x? If you go to the very first page of your textbook, you will get a list of formula there. Okay, so that will be pi and then 0 to pi. Let me keep that 0 to pi. What is sine x? 1 minus cosine 2x over 2 dx. That's how it works. Okay, cosine 2x over 2. All right, now what is the integral of, now we will split that pi 0 to pi 1/2 minus 1/2 cosine 2x dx is here. See that? What is the integral of cosine 2x? So integral of cosine, let me use a different color for the formula. So integral of cosine ax dx will be, the formula will be sine ax over a plus c. That's what you get. But since it is definite integral, you don't need c. The idea here is, you write sine ax and divide by, how do I get that? If you set that quantity as u, if you do the u substitution there, you will get that. Okay, so that's what the formula is. So I'm going to do that. So there is pi, okay, and what is the integral of 1/2? It is 1/2 x minus 1/2 sine 2x over 2. That's what you get. Okay, what is the limits? 0 to pi. So let me write down here, it is basically pi, okay, and then 1 over 2x minus 1 over 4 sine 2x, right? And then limits are 0 to pi. Let us plug in the limits here. So what do you get? If you plug in pi, you will get pi and then pi over 2, because if you plug in x equals to pi, minus 1 over 4 sine 2 times pi. What is sine 2 pi? Sine 2 pi, that is 0, right? This quantity is 0, minus, now plug in 0, 1/2 times 0 will be 0, and 1/4 sine 2 times 0, sine 0 is again 0, so that will be that one. Okay, so again, as I just mentioned, this value is 0, right? So that will give you the final answer as pi squared over 2 is the final answer. Okay guys, so that's how we finish this this chapter 7.2, section 2, chapter 7. Okay, so basically you try to find out that the length of that solid, right? Because if you are basically, if you are rotating this region, if you're rotating this region around x-axis, then the shape of the solid will be like this, right? And then you see that this is what you see, the from the left side, the cut is like a ball, but it is solid everywhere. That's what it looks like. In this case, if you're rotating, then you need to find out that is the radius of that ball, right? Of a random radius. So it is y coordinate. So it will be like pi a to b y squared dx. See that? But if you are rotating around y-axis, this one around y-axis, right? That's what the reason. And if you're rotating around y-axis, how would that look like? That would look like this, right? That the solid you obtain by revolving around that will look like that, right? That will be the solid. Now what will be the radius there then? So the radius of the solid will look like that. That is the radius, right? What is that radius? Is the x coordinate. You see that? So the volume will be, pi and then c to d, because this was a and this was b, but here this is c, this is d. So c to d and then x squared dy. Okay, but in this case you need to solve your equation for x, and then you plug in that x is basically gy squared. But instead of rotating around x-axis or y-axis, if you are rotating, for example, let's say that you are rotating, this is let's say 1, and then if you are rotating the similar shape around 1, if you want to rotate this shape, okay, so how that look like? That will look like this, right? That will look like this, and then it will look like, it will be the top, the bottom one will be like this, and then the bigger one look like that, right? This is the solid look like. So if you don't know how to draw the figure, it's okay. Just say the region that you want to rotate. Just say the region you want to rotate. Okay, just this one is okay. Now, so how do I find out the radius? This will be the actual. That will be the actual radius. That will have a thickness. That will be the thickness, right? That will be the thickness. So how much would that be? If you are rotating about y-axis, okay, then it will be pi and then that thickness, right? So c to d, c is that value, d is that value of y, okay, c to d, and then that thickness square, that will be the radius effective. How much is that? That will be, the total will be x, right? The total will be x for that. For the outside one, for the whole outside, it will be x squared minus, and for the inside one, find out the volume of the inside thing. That will be that, let's say this is whatever value of x is, right? You can say this is, let's say this is x2, this value of is x1, x2 squared minus x1 squared, and then dy, and then you plug in the value of x1 and x2, okay? But if you are rotating around certain different line, then you will do the similar thing, okay? You need to find out the length of the thickness, that thickness of the solid, okay? That thickness is changing at every point, it is changing, right? So that thickness is little shorter, that little lower, smaller thickness, little bigger thickness on the bottom part, right? That's why you need to have x2 is changing. So the x2 will be solved in terms of y, x will be solved in terms of y, but that x1 look like a constant value of x1, so it's like 2, 3, 4, whatever there is, okay? So that's how you find out the volume. All right, guys, so we will do section 7.4 next. 7.3 is still finding the volume, but different way. It is called shell method. Instead of cutting in the, just taking a random shell, we will be taking a vertical cylindrical, instead of taking random disk, we will be taking cylindrical shells in 7.3. So I'm skipping that one because it is doing the same thing, finding the volume of a solid using integral. So what I'm going to do next is chapter 7.4. All right, thank you.